Question 4 is coming from trigonometry, part A. Show that the equation cos theta into 7 tan theta minus 5 cos theta is equal to 1 can be written in the form A sine squared theta plus B sine theta plus C, which is equal to 0, where A, B, and C are integers to be found. All right. So here we shall have cosine of theta. Then inside here, tan is the same as sine over cosine. Not so? Then minus 5 cosine of theta, which is equal to 1. Now, this one can cancel with this, so we shall remain with 7 sine of theta, and then cos theta times this, that one will be minus 5 cos squared theta, which is equal to 1. Now, using the Pythagorean identity here in trigonometry, cos squared theta plus sine squared theta, which is equal to 1. Since this one is in terms of sine, then I will express cosine in terms of sine. Okay, so minus 5, here I'll put 1 minus sine squared theta, which is equal to 1. And then when we open the brackets, of course, this is 7 sine theta minus 5, then plus, because a negative times a negative, you get a positive. So 5 sine squared theta. Then I can take this one this side. It becomes a minus, right? So minus 1, which is equal to 0. So meaning we shall have 5 sine squared theta, 5 sine squared theta, then plus 7 sine of theta, and then lastly minus 5 minus 1, that will be a minus 6, which is equal to 0. So you can see that A is a 5, then B is a 7, and then C is a negative 6. Don't get confused, because here I have a negative 6, and then here they have plus C. So they said A, B, and C are integers. Those integers can be positive or negative whole numbers. So that is that for this part here. Then part B, hence solve the equation. By looking at the two equations here, you can see that where there is theta here, it is now 2x. Don't you see? 2x. 2x. That means I'm going to go to this one that I've gotten, and then wherever there is theta, I put 2x. Okay? So we shall have 5, then sine squared 2x plus 7 sine of 2x minus 6, which is equal to 0. And this is a quadratic in sine of 2x. So I'm going to use my calculator again to solve this one using factorization. I will go to mod, then 5, then 3. I'll put 5, then 7, then negative 6. So this one will give me 3 over 5 and negative 2. So I will skip space and I write sine of 2x is equal to 3 over 5, and sine of 2x is equal to negative 2. We need the factors from which these ones are coming. So you cross multiply, bring the 5 here, then after bring the 3. So that will be 5 sine 2x. Then when you take the 3, it minuses from there, so minus 3. And then take this one this side, it will become a plus. So we shall have sine of 2x, then plus 2, which is equal to 0. When I take the arc sine of this one, it is the calculator will give me math error, because sine does not go beyond 1, and neither does it go beyond negative 1. So its minimum point, its minimum value is a negative 1, and its maximum is a 1. So here we don't have any solution. So this is undefined. Then we can just go with this one here. So we shall have 2x, which is going to be equal to the arc sine of 3 over 5. Now this one here is positive. So meaning we are supposed to pick angles from the quadrants where sine is positive. So in the first quadrant, everything is positive. Here, sine is positive. Here, tan is positive. Ordinary cos is positive in the fourth quadrant. So we have 0 here. When we go anti-clockwise, the angles are positive. When we go clockwise, the angles are negative. So here we shall have 90 degrees. This is 180. This is 270 degrees. And by the time we come back here, this will be 360 degrees. If I have an angle here, let's say it is theta, and the same angle that I can project here, then I extend this one here. Opposite angles are equal. And also here, the same theta. So to move from here up to here, it will be 180, then minus the theta. Okay, so we shall get 180 minus theta. That is how you get the angles in the second quadrant. Then in the third quadrant, you will get 180 plus the theta. So that will be that plus theta. And then in the fourth quadrant, we shall say this 360, then minus this theta here. So we have that 360 minus the theta. Okay, now from here, since we are going to divide by 2 to get the x, it is better you first get a pair. Okay, and the pair of the angles we are going to get, since this one is positive, we are going to get the acute angle here in the first quadrant. But then the second angle is going to be here. Okay, so we are going to have, first of all, the arc sine of this one here. You are supposed to pick the two angles in the two quadrants where sine is positive. That is in the first quadrant and second quadrant. When you look at the domain is in degrees. So that means whatever we are having here should be in degrees. My calculator is already in degrees, so shift, then arc sine, 3 out of 5. This one gives us 36.9. 36.9 degrees. Then the next one will be 180, then minus that acute angle we have gotten, the 36.9. Okay, that will be the 2x. But what will be x? It will be a half of this 36.9. Okay, and also a half of this one here. Okay, actually, I'm going to leave this one to 2 decimal places. Since I'm going to divide, okay, by 2, I'm supposed to round off at the end. So this is 36.87. Let me write 87 here. 36.87. 87 here. 87, and then 180 minus 36.87. Now I can finally write my answers to 1 decimal place. So what is this one divided by 2? Already the answer is here, so I will say times 0.5. That will be 18.4. 18.4 degrees. Then the next one will be a half, that is 0.5. And then inside here we have 180 minus the acute angle we got there. So I'll just put it like that, and then I get 71.6. 71.6 degrees. All of these ones at 1 decimal place. So that is that.